Good morning, and thank you for joining us for our Fluke ii900 live demo webinar. My name is Corey Glassman. I'm the Global Training Manager, and I will be your host for today's presentation. Our presenter today is Dave Robley. Dave has been with the Fluke Corporation since 1984, recommending test equipment solutions for customer applications relating to thermal imaging, vibration tests, power quality, electrical measurement safety, and motor drive troubleshooting. Dave has level 1 certification in both infrared thermography and vibration analysis. And Dave holds a BSEE from Marquette University and currently works as a sales application manager based in the Chicago area. Today's presentation is being recorded. You'll see an area where you can type in questions. So if you would please do that as questions come up, we will address those at the end of the presentation. Today's presentation will take approximately 40 to 45 minutes, and there's plenty of time at the end for questions and answers. Dave?
Sounds good. Thanks, Corey. Well, I want to thank all of you for having us in virtually to share some time today. As Corey mentioned, be roughly 40 to 45 minutes. We'll be really taking a look at air and gas leak detection in facilities and exploring an exciting new technology called acoustic imaging and go into how it can help save significant money and time in facilities. Part of the 40-45 minutes will be a PowerPoint presentation with a couple of videos, but towards the end, about the last 10 minutes or so of that time, we'll be going in and actually doing a live demonstration of the product so you can get a little bit better idea of the usage of the tool, how you use it, the user interface. As Corey mentioned, you might have questions, of us, and so you're free to type those in the question box as we go along. If it's okay, we'll be waiting towards the end to address those, but we should have plenty of time. We have some questions of you too, and along the way we're going to be pausing, and Corey will be putting up some poll questions that we ask in order for us to find a little bit more about you and actually help aim our presentation even better as we're going through it. And hopefully at the end of this, you should have a better idea of whether or not acoustic imaging would be of value at your facilities. And with that, we'll get going. First, we'll take a little bit of a look at the background behind leak detection and why there's value there. Many of you may or may not know that typical plants that are relying on compressed air have systems that, especially those that have not been well maintained or those that don't have a leak detection and repair program, typically you're losing anywhere from about 20 to 30% of your total capacity of your compressors. And that's actually, that's not a fluke statistic, that's actually typical across industries according to the Department of Energy. So what does that really mean? Well, let's take a look at a specific example of, let's say if you have a 200 horse compressor operating 24/7 all year long, and your base electrical rate is 8 cents a kilowatt hour. Typically it'll cost almost $90,000 annually from an energy standpoint to operate that compressor. So if you look at that, 20 to 30% of that output is wasted. That's getting up between 25 and 30K of wasted energy cost. With the proactive leak detection and repair program, it's also been shown and demonstrated that you can reduce that to 10% or less of that compressor output. So pretty significant savings, and it's a worthwhile activity. There might also be some other types of impacts, not just energy waste, but if your production process relies heavily on compressed air and you don't have adequate supply at the point of use, that can adversely affect production. It could cause shutdowns or even product waste or scrap, depending on the the type of product that's being produced. It also does have an impact on your compressor or compressors that you have on site. The more that they have to run, the longer that they have to run and cycle, it's going to shorten the life of all those system components, leading to maybe excess capital expenditures on new compressors. Also, what we've seen is that sometimes through a leak detection program, let's say if you have multiple compressors on site, you have a backup and then maybe 2 or 3 more on site. By implementing leak detection, you can actually drop a whole compressor from running. Again, big time savings. And I've spoken with some customers that their backup compressor was actually needed all the time. So they were in a situation where they really did not have a backup. So bottom line, there's value in performing leak detection. It's expensive. It's a recurrent problem. It's not a one and done. So if you fix them, I've heard the analogy, they're like weeds in a garden. Leaks keep popping up. So it's an ongoing activity that should be performed with ongoing benefits. I think this is probably a good time to pause here for our first poll question, Corey. What have you got?
Okay, well, we're going to launch a poll right now, which is how important is air gas leak detection to you or your company? So let me launch that, and we'll leave this open for a couple minutes. If everyone on the line can take a moment to select one of those, then we'll share the results.
Sounds good, and yeah, that's good that you also mentioned gas, not just air. Air, of course, being a gas, but there's also a lot of leak detection or value in leak detection of other types of gases. We'll touch on that a little bit too. Other than air, obviously air is free. The energy to run compressors is not, but you might be using other gases on site. Other gases like argon, hydrogen, nitrogen, carbon dioxide, helium, a wide variety of gases, all of which have a cost. You have to pay for them. So there is an additional impact there in addition to running compressors for those gases. There's additional impact perhaps in the cost of the lost gases themselves.
Okay, Dave, we have about 50% of the people that have voted. Do you want me to go ahead and share the results here?
Sure, that sounds good.
So let me shut that one down and let me share this. And there you have the results. So you can see that for 38% of them, it's actually very important. And then B and C, moderately important, slightly important, balance out at about 25%. And some of them didn't really feel that that's important for them.
Okay. Well, it sounds like the majority of the people, about 60, close to 65%, feel it's very important or moderately important. So good. Good to know. So we'll kind of move on to where is compressed air and gas used. Those are some images and examples. Wide variety, widespread usage across all industries. Any type of manufacturing, heavy industry, steel mills, foundries, automotive, electrical utilities, water, wastewater utilities, food and beverage, even healthcare and more industries. So it's very, very widespread usage. So it's not really particular to one industry. And a little later, I'll show some examples of different types of leaks and also make some reference to some of those industries. So we did talk about the costs of running a 200 horse compressor with 25 to 30% of the output lost. This is another statistic from the Department of Energy. That first bullet right here is that a single 1/8-inch leak in a compressed air line can cost, again, depending on your base electrical rate, anywhere from $2,000 to $5,000 a year. And that's just one leak. in my experience, most facilities don't have leaks in the single-digit quantities. It's dozens or even more than 100 leaks at a time. So the costs can very quickly add up. And again, keep in mind that typically plants that do not have some sort of leak detection and management program are losing between 20 to 30%, and there can be certainly adverse effects from production. Also, I will point out at this point, I've run into some situations where not just pressure, but vacuum is very important to customers in their manufacturing process. Was actually talking with one customer that they make boats, and part of their manufacturing process on the hulls is to use a vacuum process. And if they can't hold or maintain adequate vacuum, it won't draw the resin in properly, and you can have varying thicknesses, so product quality issues and out and out scrap. So it's not just pressure, but vacuum as well. I think at this point, Corey, why don't we, before we go into our next topic, which is what really is acoustic imaging and what do you use it for, how about we do our second poll question?
Okay, perfect. So in this one, we're going to be talking about which is the most important and beneficial leak detection application to you or your company. So please take a few moments and select one of those following.
Really what we're asking this for is just get a little bit better feel for those of you in the audience to determine really what is it for you that would be most important, whether it be energy savings or production related improvements, minimizing downtime, just again to get a sense of what's important to you.
Okay, we have actually really good output on this one. 82% have voted, so I'll give it another 4 or 5 seconds, and then we'll shut that down.
Sounds good.
Okay, let's take a look at this one here, and I will share this. So 50% actually compressed air systems, energy cost savings. So energy cost savings does come out on top. We did have 21% for safety issues, high pressure, steam, dangerous gas leaks, and then matched at 14% each, finding leaks on purchased gases such as CO2, nitrogen, and others, and production or related issues, so downtime, which obviously is very costly, and inadequate pressure.
Okay, so it is spread, if not quite evenly, pretty much across the board there. Well, that's good. And the good news is that in all those areas, again, if you implement a leak detection program, there can be benefits in all of those areas. So now we're going to explore a little bit about acoustic imaging. What really is that, and how does that relate to leak detection? Essentially what acoustic imaging is the principle behind or a good technology behind leak detection is using ultrasonic. The idea is that if you have a air or a gas under pressure escaping through an orifice, it will emit sound up in the ultrasonic range above 20 kilohertz. It's been a technology that's been in use for quite some time. So that's the acoustic part, the ability to pick up the ultrasonic noise, we'll call it, that leaks can emit. Again, can be vacuum leaks or pressurized leaks. The imaging part is to make visible that leak source, which will greatly aid in the ability to detect and locate where that sound is coming from. So essentially, as is evidenced here on the images, it's really visualizing leak location to make the detection much easier, much faster, and visual. So essentially, making those ultrasonic measurements and then being able to create a sound image or a sound map overlaid on top of a camera image or camera display. This is an example of our acoustic imagers, and this would be the side of the tool that has detectors. So essentially there is a bank of 64 microphones in a special arrangement in order to receive that sound in real time. So it's picking up anywhere from down in the audible range all the way well up into ultrasonic range, each one of these microphones. And what is measured then is determined what frequency that sound is exhibiting, or where do we hear it essentially, and also something to indicate a relative sound level or a dB level, or some people refer to that as a sound pressure level or an SPL. So all these mics are receiving sound, and we have an algorithm inside the tool that can actually locate and determine where the sound is coming from, and then create that sound map, which is superimposed on top of a visual display as a hotspot. Very similar to those of you that are familiar with infrared cameras, you can see hotspots or hot connections. This visualizes leaks in terms of that, actually creates a hotspot on the screen. So essentially, you can imagine the tool is picking up sound from all different directions. It actually sound and up in the ultrasonic range bounces off of objects as well. So the tool is picking up all that. We'll circle back to that concept of reflected sound and how this tool gives you the ability to very easily sort between a leak source and reflected sound from a leak. So the tool picks up, and let's say we have a leak coming from this direction. How does the camera know where to put the sound on that on the image? Essentially, if you can imagine, sound has a finite and known speed. So sound from a leak source off to the left of our display here will arrive at each one of these microphones at a slightly different time. The tool is able to process that, and that is used to help determine where that leak is actually put on the display. That all happens automatically, and it all happens in real time. So you're looking at a live camera image, and you will see leaks in real time. As I mentioned before, ultrasonic has been a tried and true technology for leak detection. Let's take a look at traditional methods for finding leaks, and we'll compare them to acoustic imaging just to get a sense of what would be the possible benefits of acoustic imaging versus traditional methods. Most of the tools that are out there are either handheld tools. Some are larger, some are more handheld, or almost look like a radar gun or a cone, where you pick up sound and you aim it in a direction and the tool picks up sound. What these tools all have in common is that they convert the ultrasonic information that the tool picks up into a sound that the operator can hear. So it's translating what you can't hear down into sound that you can hear. So somebody would walk around and essentially listen for leaks using the headphones. And that works. However, you do need to have training to be able to sort between different types of sounds to determine, is this really a leak from a leak source? And then to try and narrow down where that comes from, you generally have to get up pretty close to the leaks. So it's very, very time consuming, and you need a trained ear. So typically it will take you 10 minutes, 15 minutes to find a single leak. And then you would walk through and have to get up pretty close to every fitting, every hose, every line to try and again find leaks. And not only that, you're faced with the challenges is this really a leak source or is this a reflection from something else? You don't have that visual feedback. So you need time, training, and a trained ear. And then once you find leaks, you do confirm, and then you would manually tag that leak, perhaps write down the location. So a very time-consuming process. If you can imagine you have 100 leaks or more in a facility, it takes a lot of time to be able to locate those leaks. With acoustic imaging, essentially what we're doing is, rather than an operator with a trained ear having to listen and get up very, very close to leaks, it's very visual. Not only that, you can actually, from a distance, you can see leaks. You might not know where the exact leak source is, but you can scan large areas at a glance and you can see there's a leak in that area, and then know I need to move closer to that leak to be able to identify the source or sources of leaks. So you can see more than one leak on a single image if you want to with the tool, and you'll see this once we move to the demo portion. We can actually take a picture of that leak and save it in the tool, so you don't have to carry a clipboard. You don't have to write things down manually. With the tool, you have the ability to take pictures, use a touch screen to provide any type of annotations that might be worthwhile when it comes to going out and fixing that leak. And something else that we'll also explore is, again, let's come back to that scenario where you have 100 leaks in a plant. You might not have time to fix all of those right away, but it sure would be nice to know, out of these 100 leaks, which are the 20 that are causing 80% of my loss. We'll take a look at a feature in the tool that actually lets you prioritize those leaks by quantifying which ones are worse than others, so you can best focus your maintenance efforts. Well, I think we have one more poll question, Corey. We just wanted to get a sense of if you're doing anything now, and if so, what might that be?
You bet. Let's launch the third poll here. So in this one, we're going to ask you a quick question. How are you or your company currently performing air gas leak detection? So please check whichever one talks about your situation.
Yeah, and this will be good. Again, we had said up front that we were going to ask you a few questions. This is so we get a better understanding of not just why it's important to you, how important, but get a feel for, if anything, what you might be doing now.
Okay, we're at about 75%. I'll give it another 4 or 5 seconds. And let me also add and remind everyone, we are getting some questions in the question poll. We will address those at the end. So remember to type in your questions as they come up. We will address those.
Good, yeah, thanks for the reminder.
Another couple seconds here, and we're gonna close it. So let's share what we've got here.
Sure.
A lot of people, 50%, are not currently performing leak detection. 21% not scheduled occasional checks, so soap and water and listening and watching for bubbles. And then 14% matched on both an in-house scheduled program with ultrasonics and outsourced, where they bring someone in as a third-party service to look at gas or air leak detection.
Okay, sounds good. Actually, interestingly enough, I'm jotting the percentages down here too, is that it might be different people, but the results are similar in terms of percentages at 50, 21, 14, 14. So, so it sounds like the majority of the people, over 70% anyway, are either not performing it now, or it's a little bit more ad hoc, not really scheduled, but a soap and water, or maybe on weekends having somebody, come in, paying them overtime to come in and walk around and listen, with their ears for leaks. Well, we talked about acoustic imaging. I think we've covered what the potential benefits might be. Again, it's time savings and ease of use. You don't need to have that trained ear nor skill in using the tool. It's very intuitive. And what we're going to do now is we're going to show a couple of videos that will highlight, in under a minute, really just a sense of what the tool looks like. Now, keep in mind, we actually will have a live demo, so we'll go into this in a little bit more depth. But the video that I'm going to show, there is no sound, so don't worry, we haven't gone away. There are annotations in the video, but it'll kind of give you the idea of the out-of-box experience with the tool, and when you turn it on, how you would start using the tool.
So Dave, it looked like you could see multiple leaks at one time on the screen.
Yes, you can. There may be some situations where you might want to do that. There may also be some scenarios in which you want to turn off that capability. So the tool does allow you to have some flexibility there. So essentially, as you saw, it's very simple. You turn the tool on and it's measuring. And again, the tool is picking up sound up in the ultrasonic range via the detector here with the 64 mics. Again, there's a special arrangement. It's optimized to be able to best not just detect, but locate that leak. That's very important. So detection and location are key. So typically a user would start to walk and then or quickly scan an area. And then if you see a leak on the screen, then perhaps move closer to that leak to then tag or identify that, save it in the tool, and move on. This is a typical flow or actually some tips for best practices. So again, it's a camera display, so you can physically see what the actual scene looks like. So you'd point the imager at the test area. You know your facilities, so you would know where to start and generally where to look. You can start anywhere from 20 to 50 feet away if you want, and you would start to look and see if you see any leaks or evidence of leaks. Note that a hot spot at those distances may be a leak, or it might be a reflection of a leak. So we'll examine that reflection a little bit more. Reflections can actually be useful because they can guide you into an area of inspection, even if you don't see the leak, as the actual leaks are more of a line of sight, but you can even use reflections again to guide you closer to where the leak may be. So you would scan, look for the hot spots, the sound map of leaks on the screen. When you see something, you would walk closer to where those are. We'll see we have another video coming up, and the angles bullet there, this is key when it comes to determining, am I looking at a leak or am I looking at a reflection from a leak? For the user, you don't have to have any specific training there to sort leaks from reflections. All you need to do is when you see something, change physically your perspective. Move physically to the left, move physically to the right, and then while keeping that hotspot on the display. If it's a leak, it will stay in the same spot. If it's a reflection, you'll find that hotspot will move with you, or it may disappear altogether. And then there are some adjustments you can make to better tune or more narrow down the size of that hotspot on the leak to even get a better view of the actual leak source. And we'll look at that in a little bit greater depth when I actually switch over to the live demo. So we have another video here, and again, this one will not have any sound. There are some annotations, but this is showing a leak versus a reflection and illustrating in a video format that tip that I just covered of changing your perspective to be able to distinguish between leak sources and reflections. That's actually one of the most challenging aspects of using the traditional ultrasonic tools that rather than visualizing the leak location, you need to listen. You don't really have that common sense approach to sorting between leaks and reflections. You need really to be able to get up on a leak source and spend quite a bit of time sorting through that. And as noted there in the video, you might be walking up to something, perhaps the leak is down underneath the equipment where you don't have direct line of sight to it, but you might see something on the concrete there. Common sense tells you, well, that's not a leak, but that's an example of how you can use a reflection to get close to the source of where the leak is. One of the things that people look at is, well, how much does it really cost to fix air leaks? And really, again, from Department of Energy studies, best practices study, there's a source there from the steel industry. Really, to repair leaks is very inexpensive versus the cost of the leaks. And it can be in that 5 to 10% range. So really using acoustic imaging, it takes what is a worthwhile process, leak detection, but speeds it up dramatically and makes it much easier. So really almost anybody armed with a few simple tips and about 5 minutes of time can be up and detecting leaks very quickly. We have some example images here. One of the things that I'll just make a few comments on these as we go along. As I mentioned, this is best used while things are up and running and including very noisy environments. And I'll address that a little bit more when we come to the live demo, but this technology works very, very well, even in very loud ambient audible noise situations. So you can detect while things are running, as opposed to some people that have used soap and water where all the production equipment is not running, perhaps on a weekend, but they're going around listening with their ears for audible noise and then applying soap and water. So this is something you can do anytime while equipment is up and running. It is line of sight technology, but it will work through screens as evidenced in the second image. Kind of a wide variety of equipment. Any type of air tools or pneumatics that are part of your manufacturing process. As I mentioned, even in utilities, both electrical and water, wastewater utilities, they will use pneumatics for as part of their process. So they'll actually have pressure instrumentation out in the field that require an adequate supply. So leaks can impact their processes quite a bit. So this tool works well in those environments, as well as overhead lines and fittings, where leaks might be more impactful. There were a number of you, I think over 20%, as I jotted down, were very interested in safety. So steam leaks can be a safety risk. So it's good to identify those leaks as well as energy loss, but definitely there's an impact there for safety. So steam or high pressure steam leaks, easy to see that. We can see here on that large flange, and you can see those at a greater distance as well. And then you can move up close to that leak source to be able to identify exactly where is that coming from. Here's an example of exhaust leaks, vacuum leaks that can be detected with the tool. Here are some examples of different gases. The principle is the same for leak detection. So here we're seeing nitrogens, maybe hazardous exhaust, maybe it's furnace gas, hydrogen, natural gas, carbon dioxide. These could all apply to a variety of different industries. CO2, that's definitely one of those purchased gases by beverage facilities in the food and beverage industry. That is, in many cases, part of their bill of materials. So waste and losses can certainly affect the bottom line, your profitability. So these are examples of different gases. Really the detection and location is independent of the gases. It is true that I'll use the term noisy. Some very low density gases are less noisy than others. So at a given leak size and leak flow rate, it might not emit as much noise, but from a detection and location standpoint, the tool works exactly the same. And I mentioned healthcare. So healthcare is one of those interesting types of markets that, yes, they have compressed air, as part of the facilities, and the tool does a great job of detecting those leaks. But there's also a variety of medical gases. There's medical air, but there are also other types of gases that are used either in patient rooms. Of course, there's oxygen, pure oxygen. Medical air is another type of gas leak that would be used in patient rooms. But then also in operating theaters, there may be other types of gases that are in use, depending on the type of surgery. So very high impact there in those industries if they don't have adequate supply at the point of use. Well, I think now we've come to that portion where we're actually going to switch over to showing my live camera display of an ii900 acoustic imager. And we'll do a little bit of a run through of the tool live for you. As you can tell, we have a leak displayed there on the screen. I'll give you a little bit of background as to what I have going on. Outside my office, I actually have an air compressor running, and it's cycling on and off, just like the compressors in your facilities. And what we have here is a tool, an air tool, in which I didn't use Teflon tape in this threaded connection. So we obviously have a leak source. I'll point out a few things. One is that the tool does have a very large display. It is a touchscreen display, so you can touch the screen to change things, and we'll go into that in a little bit. And I'll also point out a few other things. One is over here on the right side of the display. Notice we have a type of a frequency display, and it's going from down in the audible range. And as you can see, as I'm talking, it's measuring, and it's actually picking up noise down in the audible range. So as I talk, it's changing down here in that 2 to 5 kilohertz range. There is also background noise up in the ultrasonic range that is being picked up by the tool. I will also point something out here in terms of the yellow box that you see on the display. As I mentioned, the tool works very, very well, even in very noisy environments. So I'm creating a lot of noise here as I'm talking, but this yellow box is really for the sound map of the leak itself. That's really where the tool is listening and displaying that sound map. Really is only up in the range that's up here. So if I move this down into the audible range, as I talk, the sound of my voice is echoing off the walls and it's picking up all that ambient noise. But as I move up into this range, which by the way is a default listening range that will pick up 80 to 90% of the leaks that you have in your facility. It's totally ignoring all that high ambient level of noise, so your production equipment, and it's showing only, or mapping only what is shown in this area. So leaks emit up in the ultrasonic and over a wide range of frequencies as well. And again, those default settings on the tool work very, very well, but there might be times where you might want to tune around a little bit just to make sure, maybe if you have leaks at lower leak rates or lower density gases. So as I showed, you don't really have to have a knowledge of what frequency range you're picking. You're more using the visual feedback on the display to best tune and display the leak. So you can move that range around. You can also click and drag to make the range larger or smaller. So now I have a very nice view of that leak. And if I wanted to document that, I would use the large green button, and it has now saved that image for me. And I'm back into a live mode. When it comes to saving images, oftentimes people's activities will be, I'll call it route-based, or they would go to certain areas of a facility. They might not want to spend 8 hours or 6 hours or 4 hours to be able to inspect a large portion of the plant. They might want to break that up over several days and maybe spend an hour or two in each area. You have the ability to actually organize where you're storing the images in the tool. In this case, I created a folder called West Chiller Plant, but you can create your own folder names, and then you can store images under those folders, and it actually will organize the images in the tool, much like on Windows. In fact, it uses a Windows file structure, and if you use the USB-C port at the bottom of the tool, and you plug it into your laptop or desktop, it will come up as a device called Fluke ii900, and it has a file structure on it, and all your images will be organized by that file structure. All the images are date and time stamped as well. I do want to go into a different mode of using the tool. I mentioned the ability to quantify leaks. We have a capability in the tool called Leak Q, short for leak quantification, that will enable us to be able to quantify that leak with the thought of prioritizing your repairs. Which leaks are worse than others? A couple things I'll point out. One is we'll have a distance to where the leak is, so we're actually measuring, and not only can we detect and locate, but we can determine the distance to the leak, and then a relative severity scale of that particular leak. And the reason why we're doing this is the tool might be a certain distance away from the leak, and I'm actually going to move my leak closer to the tool, or to the ii910, and I'll move it further away. And you can see the distance is changing. That's important because it's very valuable to know not just what that sound level is at the sensors or at the microphones, but to be able to compensate for how noisy is that leak here at the leak source. So that's what the tool is using that distance for. It's really to compensate that dB level, or how noisy is that leak at the leak source. Because if you know that, then you can do an estimation on leak flow rate and prioritize your leak repairs based on severity. So that's one of the reasons. And then that leak Q scale, again, will help you determine, which leaks are worse than others to, again, affect repairs in a prioritized fashion. So if we wanted to save this, we go about it the same way. So now we've essentially frozen that, taken a snapshot. We're not really updating right now. And this gives me an opportunity to show how we can add notes. This would be free format text annotation that you can add to your leaks. Again, with the thought of what information would somebody need to know to be able to best affect repairs. You can add pictures, photo notes, use this as a camera. There may be some production equipment labeling or tags that might be useful to save to best locate what area of the plant you're working in. You can also add what are called tags. Type of leak, which can actually help with the estimation of severity. What type of gas are we dealing with in this leak? If you happen to know the actual pressure at the point of usage, that can again help better fine-tune your estimation of the severity of the leaks. And you can key those numbers in. All those tags essentially are saved with the leak image. And at this point, then you would hit save. And then we're back to again, a live mode. That really concludes the demonstration portion. So I'm going to switch back over to the presentation. And at this point, we'll open it up for questions. We'll field the questions that have been coming into the chat, or I'm sorry, the question box along the way.
Great presentation, Dave. Thank you. There are some questions coming in, so please use the chat window to type in your questions now for Dave, and we'll address those. The ones that we're getting so far, there's one that doesn't detect freon gas.
So freon gas, typically a refrigerant. And the answer is it really depends. It's not so much gas dependent as the size of the leak and also the pressure, and then the orifice size of the leak. So it's one of those situations where possibly so, and again, it's gas independent, but more the nature of the types of leaks. Specifically in refrigeration systems, I know that some of those leaks can be extremely small, extremely low flow rates, and acoustic imaging might not be able to detect all leaks in those situations. Many times in systems like that, the actual refrigerant may have a dye in them, and there are other types of tools that will emit ultraviolet light to be able to visually observe leaks. There are also, in cases where acoustic imaging doesn't work necessarily, refrigerant leak detectors. So versus a listener, as in acoustic imaging, they would be more of a sniffer type of a tool.
Beautiful, thank you. How well does acoustic imaging work in a really noisy environment?
Yeah, and that's a great question, and it actually happens to be pretty much the #1 question that as I meet with customers and we go on site, we'll kind of talk about that sound mapping and how that works, and they'll say, but yeah, my plant is really noisy, and really the ability to be able to selectively sound map in that yellow box that I was moving in the live demo, that gives you the ability, or gives the tool the ability to really only listen into that frequency range and ignore everything else below it and above it, to be able to map only the sound that the leak is producing. So it's very effective, even in very noisy environments.
I think you answered this question, but maybe you could show them the bottom of the imager with your camera, if possible, because I think you said it had a USB. The question is, what can you do with the image after saving it?
Ah, great question. Yeah, I'll switch back over to the camera display. So let's say you've gone through, you've done your survey, and you've stored images under a folder or various folders. Typically, you would go back to the office at that point, and you would hook up the tool via a USB-C cable that comes with the tool. You'd hook this up to your laptop or your desktop, so it's a USB-C to USB-A cable that comes with the product. And then you would turn the tool on. You would see a file structure on the device under storage, and then subfolders that would be based off of the folders that you've created. So image files are all stored under folders. What you can do then is we have a reporting tool called the LeakQ reporting tool. It's an online tool where you would take those files that are stored on the imager, physically copy them off the imager into a similar file structure anywhere on your laptop or desktop. With the online reporting tool, then you can take those files and actually drag them into the tool. There's the online reporting tool. There's a box that you can drag and drop image files, and then from there you can actually go through that estimation and even provide some cost estimates, again with the thought of prioritizing leak repairs. Fix the most impactful ones first. But what you can do is feed the tool a little bit of information. What type of gas are you dealing with? If it's air, there's no cost to the air, but you feed it information on compressor runtime. Is it running 24/7? Provide some information to the reporting tool. Click generate report, and it'll generate a PDF on a leak by leak basis with the image, CFM or cubic feet per minute flow estimation, and then a cost based on your utility base rate, and then also the compressor runtime information. So you get a report essentially with a summary of all of your leaks, as well as on an individual leak by leak basis that you could use page by page of that PDF to direct maintenance repair efforts out in the field.
Okay, here's a few others that are coming up. Let me see. What's the lowest pressure or smallest leak we can detect with acoustic imaging?
Yeah, it's probably the second most asked question, after does it work in noisy environments? And there is not one set definite answer, because it does depend on a number of things. The distance to the leak size, the pressure, the orifice size of the leak, so that flow rate. So the answer is it depends. It's not a particular minimum at one particular distance. So it really depends. And in my experience, we've been able to see leaks down into some pretty low pressures, into single-digit pressures, and we've been able to get up pretty close and some fairly low flow rates on things like natural gas, for example. So it's not a hard and fast number. We do provide an example spec of typical shop air or pressure in a facility might be in the 100 psi neighborhood, and we can see leaks as small as 5/1000ths of a CFM at 30 feet. So again, you can see smaller leaks from closer distances, smaller orifices, lower flow rates, lower pressures, but the answer is it really depends.
I see you're using an ii910. What's the difference?
Ah, yes, somebody picked up on this. Okay, we do have two acoustic cameras. They both look identical. They operate identically. The ii910 has even better sensitivity than the ii900. So if you are dealing with, in particular, vacuum leaks, they're tougher to find than pressurized leaks. So if vacuum is important to you, you're looking for vacuum leaks, you might want to consider the benefits of having the better sensitivity for vacuum leaks, as well as maybe lower density gases, hydrogen, helium being example. They're less noisy, especially at low flow rates. This can pick up quieter leaks essentially than can the 910. And beyond leak detection, the ii910 also adds another type of leak detection, really for more the electrical world. It's called partial discharge, for showing evidence of arcing or tracking or arcing kind of along conductor surfaces or insulation, even for a little bit clearer picture here, even in medium voltage or high voltage environments. So there's applications at utilities for partial discharge detection, as well as at substations or large industrial facilities that have medium voltage, say 4160 volts or 13,400 volts, for example.
And then there's one final question here, and guys, keep them coming while we have Dave on the line. So this one is, can Fluke acoustic imagers tell which leaks are worse than others in order to prioritize the repairs?
Yes, they can. And one of the ways of doing that really would be to use the leak queue image mode versus image. Leak queue will determine or detect the leak, locate the leak, determine the distance to the leak, compensate for that distance. So to be able to tell you what is the noise here at the leak source versus at the detector itself, because you need to know that. What is the noise at the leak source? And then it will, based on all that information, create a leak queue number, which is a prioritization scale. And when you bring those images into the reporting software, then it will convert all that information over to provide an estimate on the leak flow rate, or CFM. And actually in the tool, you can take all of your leaks, 100 leaks, let's say it is, export them over to Excel and quickly sort on that number to prioritize the leaks.
And then there's one other question. I know we're within about 2 minutes of the end of the presentation, but this one just popped in from Todd. When selecting the image type, such as image and video, I do not have a leak queue question or option. Is there an update or registration that I would need to do to access that?
Ah, okay. So this sounds like somebody that already has one of the acoustic imagers, probably the ii900, as that tool came out first. Yes, we do have a free firmware upgrade for the tool, and it is on the fluke.com website. Under our support section, there is a selection for software downloads, and that also incorporates not just software, but firmware updates. So if you were to navigate to that, you could, in the search box, you could type in acoustic imager or ii900, and that would take you right to where you could download the upgrade. It's something you can do yourself. It is loaded into flash memory in the tool. And all the instructions for doing so are right there where you can download the update. And when we went from version 3 to version 4, it was a free update, by the way. we implemented Leak Queue as well as the folders that you see down here and other options, as well as the partial discharge detection in the
Well,
910.
I just want to thank everyone for taking their time today, for joining Fluke for the ii900 live demo webinar. We hope you enjoyed it. And Dave, definitely thank you. You'll receive an email after the webinar where you'll have an opportunity to read about some additional materials that we'll send out about the product. We have an ROI calculator that we'll also send that'll help you identify the sort of where costs can be returned by using this type of tool. And you'll have an option to speak to somebody if you have further questions. So I just want to personally thank you and have a great day.
Thanks, everybody. Thanks for inviting us in virtually today.